A 3 kg mass is attached to a spring of stiffness 120 newtons per meter and is displaced 0.15 meters from its equilibrium position. Find the time period of oscillation, that is part A of the problem. Then part B, determine the speed of the mass when it is 0.1 away from equilibrium. Alright, so here we've been given the mass. Our mass is 3 kgs. Then we have the spring constant of 120 newtons per meter. Our spring constant K is 120 newtons per meter. Then we've also been told to say the displacement is 0.15 from equilibrium position. So the displacement from equilibrium position is known as amplitude. So our amplitude is 0.15 meters. Now we are told to find the time period of oscillation. So our time period will be t equal to 2 pi. Since angular frequency is not given, the expression we are using is 2 pi times square root of m over k. Now from here we substitute the value, so we have t is equal to 2 pi times square root of our m, according to the question, is 3 kgs over our spring constant is 120. Computing this gives us our period of 0.99 seconds, and first part is done. We now move on to B. So B is simply telling us to find, or rather determine, the speed of the mass when it is 0.1 meters away. So here our displacement is simply 0.1 meters, and with this displacement let us find the speed. So being that this is not at mean position, what we're going to do is the expression for speed we're going to use will be v equal to square root of k over m multiplied by amplitude squared minus x squared, like this. Then now we substitute the values, so we get v equal to square root of k is 120 divided by m is 3 kgs times a being the amplitude, which we have is 0.15, then this squared minus x is 0.1 squared. Upon computing this, we simply get our speed of 0.71 meters per second, and the question is done. Thank you very much for watching the video.